In Part 5, we continue with a discussion of the history of quality. During the 70s, the Japanese automobile companies started to have a huge impact on American market share, taking about 5% a year away, most of that from General Motors. I worked for General Motors at that time, and I remember it well. One of the things that we noticed was that some of the methods started to leak over to the United States. One of those was quality circles. Here in the United States, we thought that quality circles were just a way that the Japanese manufacturers could get employees involved and make them feel good about their work. And so we started some feel-good quality circles, never really understood much about what was going on, but we tried them anyway. Most of those efforts really didn't go anywhere. But during the 70s, there was just the beginning of concern about what was going on in Japan. In the 80s, we started to pay more attention, and we learned that they were using statistical process control, and they had quite a supplier quality movement going on. It was not just suppliers being located near the company, but it was more of a partnership between the two in many respects. So we started to pay attention to that, and the supplier quality movement began. The automobile companies were probably the first to get involved, starting their own quality monitoring systems. About 1985, we got wind of Taguchi methods, which was a way of implementing design of experiments to find the best settings to use for production and other operations so that they were the least impacted by uncontrollable variation. Taguchi methods enabled engineers to design a lot of things cheaper, better, faster. So during the 80s, we started to take notice of the supply chain and different methods that the Japanese were using. That was also the period of time when Deming was doing a lot of his 4-day seminars. Around 1990, a lot of these different techniques got packaged into what we ended up calling total quality management or continuous improvement programs, which we'll discuss a little more on another slide. A lot of people attributed total quality management to Deming, but he didn't like that terminology. He claimed it wasn't his philosophy, but really it was a lot of the same techniques that he was teaching mixed with some of the things the Japanese were using, all rolled into total quality management. That continued, and in the mid-90s, supply chain management started to become more prevalent, and that was looking deeper at what was going on with a company's product line from the very early stages, from the earliest suppliers all the way to the end users. And the idea there was that if you could manage not just your own company, but if you could manage up and down the supply chain, you could greatly reduce your costs. And I believe that's what kept General Motors alive in the 90s, was they did take a lot of money out of their supply chain. Another concept that came up was the learning organization. We'll talk more about that later. That was popularized in a book by Peter Senge. And there we're talking about getting companies, management particularly, into a mode of being concerned about learning what works and what doesn't work, share it, and then keep learning more. In the late 90s, Six Sigma quality started to bloom, although it was invented in the late 80s by Motorola. It didn't really take hold until the late 90s with a lot of the companies. It's still around today. It's morphed quite a bit, and of course that's the main theme of this particular certificate program. In the 1950s, after World War II, there wasn't a lot of manufacturing going on outside of the United States. Germany and Japan were recuperating from World War II. And so during the 50s, quality was nice, but just getting a hold of a product was what was important. Then during the 60s, people started to think a little bit more about quality. Companies that were still in the inspection mode associated quality as being more cost. They didn't really look at their success being tied to quality, they looked at it as being tied to their cost and their profit. But during the 70s, quality started to become important as customers started to get high quality products, particularly from Japan and companies like Motorola. But as they started to get quality products, they realized they liked them, and it started raising the bar. Customers became more aware of quality and started demanding it more. So besides customer awareness, there were other things that started to happen. Product liability costs started going up. And then also we started to become concerned about the supply chain, what we were doing, what we were using for materials. What about sustainability? Were we using things that we could continue to get? I remember, for example, automobiles used to have chrome all over them. Now you can't find chrome on an automobile. Mining chromium and the cost of chromium in the world has become a real issue and a scarcity. Companies started demanding that their suppliers produce less scrap and waste, and companies started to spend less on energy as the costs went up. So quality became an issue of competitiveness both in the country and outside the country, especially as the global marketplace started to shrink. So some companies recognized this, and the quality movement took off, and quality became a business strategy. So enter around 1990 the Total Quality Management, or TQM movement. Let me summarize this on this slide, and let me say right up front that none of these things have really gone away, but we'll talk about why the TQM movement didn't really have as big a splash as it should have. These are some of the major tenets of the TQM movement. First of all, the concept that quality is the job of everyone in the organization, not just the people in the inspection department. Now, some of you may think that this has always been around, the idea that quality is the job of everyone. But in many places, and especially some of the places I've worked at, quality was the job of the quality department. Everybody else's job was just to get the work out the door. Another tenet of TQM is the use of teams to solve problems. This is an offshoot of the quality circle movement, but done in a slightly different way. Another concept is the idea of internal and external customers. You were responsible to know who your customers were. In other words, every time you did something, who was going to use it within the company. Those were your internal customers, and then of course being concerned about whoever bought your product or service, what did they need. So the idea was to constantly work on customer satisfaction, never quit working on it, continually try to satisfy the customer. Another tenet of TQM was to use statistics to identify and solve problems. This is data-driven problem solving. Now, the degree to which statistics was used in TQM varied quite a bit from company to company. Some companies may not have even included statistical techniques in their TQM program, and others did quite a bit. Finally, continuous improvement was the goal. And some companies titled their program Continuous Improvement Program, Continuous Process Improvement, various other acronyms instead of saying TQM. The concept of ideal is probably one of the most critical topics that I can present at this point in the program. What we're talking about is ideal versus good enough. Let's use a field goal, for example, in the world of football. If you kick a field goal anywhere between the goalposts, it's 3 points. So anywhere between the goalposts is equally good as far as the scoring is concerned. That's the same mentality that we use sometimes in manufacturing when we have specification limits. If the part is within the specification limits, we say it's a good part. If it's outside of specs, it's not a good part. So the goalpost mentality is pretty much what is used in many manufacturing situations. But in reality, when we're making a part, not all parts within specifications are equally good when it comes to how the parts will work and interact together, or where the lowest cost point is. And really what we have is a target that we would like to hit that would reduce the cost if we could figure out what it was. And that is a different mentality, because with a target mentality, it means that we're not good enough. We can keep getting better and better as we can reduce variation and get closer and closer to the target. So it's not just a matter of what's good enough, but what is the ideal target and how close are we going to get to it. Well, this difference between the target mentality and the goalpost mentality is crucial in the world of continuous improvement. One of the criticisms of Six Sigma is that it appears to have a goalpost mentality. But my experience is that many of the Six Sigma programs do concentrate on getting close to the target. So anyway, this is really an important point, and it'll be brought up again. Probably one of Dr. Taguchi's most enduring contributions to the world of quality is what we call the Taguchi loss function. Here we are talking about finding a target value that reduces cost or minimizes cost for a particular feature. And Dr. Taguchi came up with an approach to find that target value based on cost, and then the goal would be to get as close to the target you can and reduce variation around the target value. This is a concept that is widely taught in the world of quality, even though it doesn't match up with the idea of the quality index CPK, which is based on spec limits. Still, there is a lot of emphasis on finding the target value and trying to get close to it. So why did most TQM efforts fail? Well, there's no common agreement about what the failure rate was other than it was high. But I think most experts would agree that the two major reasons for failure were: one, lack of upper management support and understanding, and two, failure of management to take responsibility for improving the system. And one quote here is, "The gap between top management's rhetoric about their intentions for TQM and the reality of implementation in various subunits of the organization kind of explains it." What I noticed was that a lot of managers wanted to implement TQM as a magic bullet, but they weren't really involved with the implementation of it and understanding what the core concepts and tools were. They had delegated that, and what that meant was there was no real buy-in in improving the system. So what is different with Six Sigma? We noticed that most of what was in TQM is also in Six Sigma, but the Six Sigma programs have succeeded where a lot of the TQM efforts failed. What Motorola did was they forced management involvement executive level involvement with the continuous improvement process. They had upper management training in Six Sigma. They held directors accountable for knowing what projects were going on. In fact, they even had to report on what projects were going on and use Six Sigma tools to explain how things were going. It was team project centered, and for once the team projects were taken seriously. They were monitored for impact and for strategic effect within the company, and then there was forced executive level oversight of the Six Sigma process. Here's a famous quote by Jack Welch, from a former CEO of General Electric, about their Six Sigma program. Let me just add that I think General Electric was probably one of the ripest companies for Six Sigma because it already had a strong emphasis on the use of statistics. And secondly, Jack Welch was the kind of a guy who had a very quantitative background, and he wasn't afraid to jump in. And he recognized what Six Sigma could do right away. And so they made it a business strategy early on, and they were very successful. I'm not going to read this whole quote, but let me just get down to the last couple of lines. It says, "Our strategy worked exactly as intended. We've almost tripled revenues, have quadrupled earnings, and have provided a 20% average annual return for our shareholders for the past 15 years. So that's a pretty impressive testimony about the benefits of Six Sigma if it's done in a way that's effective. One of the major contributions of the Toyota production system was the concept of lean, which is a broad term referring to removing waste of all kinds from your systems. That's reducing inventories, reducing the cost of labor, non-value added operations, eliminating mistakes and bottlenecks. Some people have tried to use lean as a competitive strategy to Six Sigma, but really they're two slightly different things, but they're very complementary. And a lot of companies have created what's called Lean Sigma. In fact, a lot of programs are called Lean Sigma that are out there on the market. And I would even contend that what we're teaching here is truly Lean Sigma. I believe they go together, and I wouldn't teach Six Sigma without Lean. Lean is nice to adopt right away because some of the aspects of Lean you can start implementing before you start going through major culture change, which we'll talk about a lot later on. But anyway, they go together. My final comment on this slide is that Six Sigma, what I've noticed from going to conferences and seeing what companies are doing, is a program, a tool that companies really customize for use in their own systems, and there is no really one way to do it. So, like I say, there are many versions of Six Sigma as there are companies using it. Here are a few examples or buzzwords related to Lean that we'll talk about more later on in other modules. One concept is called 5S. The 5 S's refer to 5 Japanese words that are basically involved with getting organized, getting things cleaned up, preparing a workplace to be more efficient. Kaizen is the concept of continuous improvement. SMED, S-M-E-D, stands for the single minute exchange of die. A lot of times, some of our production costs are tied to changeovers or setup time. If you could reduce setup costs to a minute or less, then you could switch from one product to another, and so you could run smaller batches, keep smaller inventories, and save a lot of money. A lot of people kind of laughed at, gee, how could you change a setup time down to 1 minute? But if you did a little of investigation, you'll find that a lot of people were able to really reduce or practically eliminate setup times for many operations. Pokeyoki is another term for idiot proofing. That's color coding, doing all kinds of things so that people can't make mistakes in grabbing the wrong part, sorting, putting things in the right hole. Um, anyway, there's lots of different things that could be done to eliminate common mistakes on operations. This is actually a very high level form of quality improvement, even though it may seem low level. It really is a technique used by world-class companies to a large degree. Finally, Kanban, or the pull concept of inventory, is the idea that nothing starts in production until an order is there to generate launching that part into the system. So instead of building to stock, you're building to order.